In this video, we're going to review covalent bonding and talk about what makes covalent compounds or molecular compounds. A covalent compound has a combination of two or more nonmetals, so there's no metals involved in this type of compound, and these molecules share electrons between them, and their bonds are called covalent bonds. So 3 examples of covalent compounds that we see here would be carbon dioxide, water, and monosaccharides. This could be glucose, fructose, or galactose, but we don't know because we don't see the arrangement of the atoms. Now there are a group of special molecules that are covalently bonded, and those are called diatomic molecules. So those are molecules that are made of 2 of the same nonmetals. So diatomic actually translates to be 2 atoms. And the following elements always form diatomic molecules. They cannot exist all by themselves. They always need to pair up with someone. So if they have nothing else to pair up with, they pair up with themselves. So hydrogen is one, oxygen, fluorine, bromine, iodine, nitrogen, and chlorine are all diatomic molecules. There's a couple of ways of remembering them without having to memorize the list. So I've written them out in this format. So if you read that all together, you could say it says Hofbrinkel, so that helps you remember them. Another way to remember them is if you look at or shade in where they're on the periodic table, it actually looks like this. So we have nitrogen, oxygen, fluorine, and then chlorine, bromine, iodine. This almost looks like a little hockey stick upside down. And then up at the top of the periodic table, you have hydrogen. So I sometimes say it's the hockey stick and hydrogen's the hockey puck. So that can help you remember which ones are diatomic molecules too. But anytime you're told that you have fluorine, it's a molecule of fluorine, not fluorine an atom. So for covalent compounds, we have to add a couple of extra naming rules. So we need to use Greek prefixes to help us know how many of each of the atoms are found. So if there's 1, you would say there's mono. If there were 2, di, tri, tetra, and so on for all of them. So it goes all the way down to 10. We normally wouldn't get past penta, sometimes hexa, but the rest of them not so much. So for naming compounds, we'll go through the rules and then we'll go through some examples. So step 1, you need to look at the number of atoms on the first element, and you choose the prefix that matches that and follow it with the name of the element. So if you had 2 nitrogens, you would put dinitrogen. And then step 2, you choose the prefix that matches the number of atoms on the second element and follow it with the name of the element. And then step 3, you change the name of the second element to ide. So imagine there were 5 oxygens. So if we had dinitrogen, it would be pentoxide. There are a couple of extra rules just to make things extra fun. So mono is never used on the first element. You wouldn't say CO2 is monocarbon dioxide. We just say it's carbon dioxide. So if on the first element there's no prefix, you just assume that there must be just 1 of those atoms. And then never use prefixes for hydrogen if it's listed first. So let's use our practice here. So our first one, we have N2O4. So on the first one, we would say it's dinitrogen. And then there's 4 oxygens, so we'd say tetra. So we blend that together with the oxygen, so tetroxide. So that's our first one. This one, there's no number beside the sulfur, so we don't use a prefix, so it's just going to be sulfur. And there's 2 oxygens, so dioxide. So when you write chemical formulas, there's so many different variety of ways that we can combine the atoms in molecular compounds or covalent compounds. So we do not use the crossover rule. We just look at the name and we work backwards. So we'll go through some examples of those. So our first one, it says we have carbon dioxide. So there's no prefix, so we just would know that it's just carbon. And then dioxide would be 2 oxygens. Another example would be nitrogen triiodide. So again, no prefix with the nitrogen, so it would be N. Tri means that there's 3 iodines. So when you draw Lewis structures for covalent compounds, you first would draw Lewis structures for the 2 atoms, and then you would arrange the shared electron pairs according to something called the octet rule. And that rule just says that all of the elements want 8 electrons, so you got to figure out how that will work best. And then you represent the bonds between them, the shared electrons, as lines. So in this example, we have nitrogen gas, so it shares 3 pairs of electrons with each other, and then they have each a lone pair of electrons. So in this example, we're going to take a look at iodine. So remember, the first thing that we do is we draw the Lewis structure for each atom. So iodine is a halogen, so it's in group 17, so it has 7 electrons. I'm going to draw the lone electron in the center, so that's where the bond is going to form. So we'll fill everything up. So we'll start 1, 2, 3, 4, 5, 6, 7 for the first one, and we'll do the same thing for the other one. 1, 2, 3, 4, 5, 6, 7. You can see here, I'm just going to change my pen. These 2 electrons are going to be shared and form a bond. So I'm just going to erase the dots and draw our bond right now. So that's how you draw the Lewis structure for iodine. So now we'll practice drawing the Lewis structure for oxygen. Now, if you look at oxygen on the periodic table, it's in group 16. So it has 6 electrons. So we'll just draw the Lewis structure for the atoms first. So 1, 2, 3, 4, 5, 6. And the same for over here. 1, 2, 3, 4, 5, 6. And now we need to figure out how many bonds are going to be, or how many pairs of electrons will be shared. So these 2 would like to share right here, and these 2 would like to share. So we're just going to fix that up and draw a double bond. So we'll get rid of those electrons, and now we're going to show the bond. So there's a double bond between the 2 oxygen atoms.